in the next section, we are going to talk about why we need to understand exposure variability. So let us consider a medium-sized manufacturing facility, and I'm showing this table. On the left-hand column shows the various departments: production, maintenance, engineering, admin, and others, the number of employees in each department, and then most importantly, the exposure tasks in each department. And so what this column means is that, for example, in the production department, there are 20 distinct tasks that workers do. And each of these tasks involves maybe 15 to 20 chemicals, as I show in the footnote in this slide, which means, as you can see in the fourth column, if you look at chemical task combinations, just for the production department, there are roughly 300 to 400 chemical task combinations. And this is what we would call an SEG, or the similar exposure group that we discussed earlier. So for each chemical task combination, if we assume that there are 250 working days per year and 2 shifts per day, we have 500 distinct exposure opportunities. And if you consider now the 325 workers in the entire facility and assume that each worker encounters 5 chemical task combinations each day, so they are sort of working in different jobs during the day, then we have, by multiplying all these things out, we have roughly 812,500 exposure opportunities. We can see that this is a tremendous number of exposure opportunities, both if you consider workers or if you're just considering the similar exposure groups. So can we sample all of these different exposure opportunities? So here, let me just pose this question. What do you think is the most common number of air samples used to make a judgment about exposure? A, greater than 10, B, 6 to 10, 3 to 5, 1 to 2, or 0 air samples used to make a judgment about exposure. And when I say judgment about exposure, going back to the example of that manufacturing facility, if you look at a particular worker or a particular SEG, how many air samples are going to be used? So the correct answer here is 0, surprisingly and shockingly. Most of the time, we meaning exposure assessors and industrial hygienists, make judgments about exposure, whether it's a safe exposure or acceptable exposure or unacceptable, on the basis of no measurements whatsoever. And the next most common number of air samples is 1, and the next most common is 2, and so on. So you can see the challenge of occupational exposure assessment. The risk manager or the industrial hygienist has to use his or her limited resources to make exposure judgments that are accurate and make sure that all the workers in his or her care are kept safe. And even though there are hundreds of thousands of exposure opportunities, the industrial hygienist makes maybe 0 or maybe 1 or 2 measurements, maybe 3 measurements, and on the basis of that, assess whether the workers in that particular similar exposure group are safe or not. So to make these judgments and make them accurately, the industrial hygienist really needs to understand exposure variability. And that is, in fact, the goal of this course. A comprehensive exposure assessment that targets each worker every time would be ideal. So if we could make 812,500 exposure measurements, that would be fantastic. But of course, nobody has the money to do that. And we, of course, also don't have the people to do that. So it's costly and impractical. And therefore, a strategy that industrial hygienists use is to sample a subset of the workers and measure their exposures and sample them only a few times. And so the occupational exposures are varying significantly from one day to the next. and from one worker to the next within the same similar exposure group. And of course, from one group of workers to the next. And so the job of the industrial hygienist really is to understand the nature of this variability, both if you measure the same worker on 2 different days, what is the variability? If you're measuring 2 workers doing the same job, what is their variability? And if you're measuring 2 workers doing different tasks, what is the variability? In this figure, we are looking at exposure distributions within the general population of workers in a workplace or people in a city or people in a community. On the x-axis, you have exposure. On the y-axis, you have the number of people. So we can look at population subgroups, people who are mixing xylene and toluene right on the table. So their exposures are probably higher versus people who are mixing xylene and toluene inside a functioning ventilation hood. So those people are maybe on the lower end of the exposure spectrum. And there are people in between. And so if we were to look at just workers exposed to this mixture of xylene and toluene, you would get this kind of an overall curve. And as you can see, and I've deliberately drawn it in a skewed way, it is not a symmetrical looking distribution. It rises up sharply, and then it has a very long tail to the right. And such what are called right-skewed distributions are very common in occupational and also in the general environmental settings. And we'll talk a lot more about such skewed distributions in a bit. So the goal of the IH, or industrial hygienist, is to have a strategy that is effective, an exposure assessment strategy that is effective. And by effective, we mean that we need to ensure that no worker has unacceptable exposures. And later on in the course, we'll see we have to sort of step back a little bit and say, we really cannot ensure that no worker has unacceptable exposures, but we can say, okay, most workers have acceptable exposures. And we'll talk about what we mean by most. But anyway, this is the ideal goal, right? We ensure that no worker has unacceptable exposures, but we also know that more than 90% of the exposure assessments are conducted without any monitoring data, without personal exposure measurements. And so how can we ensure that workers are protected? So industrial hygienists should follow an exposure assessment strategy. And one such exposure assessment strategy is shown in this particular diagram, this flowchart. And this is the exposure strategy described by the American Industrial Hygiene Association, or AIHA. And this is just an example strategy. There are strategies in the European Union, in South Korea, in Japan, but they are all not very different from this one. So we're just going to use the AIHA strategy as our model for this course. And I'll briefly talk about it. It's very similar to what we have talked about earlier. So we start off, and the reason I have an oval which says start is because a lot of organizations don't have an exposure assessment strategy. So they just sort of willy-nilly make measurements, and they don't really have a good way to interpret those results. So we need to have a written down exposure assessment strategy, followed by a basic characterization, which I talked about earlier, is the industrial hygienist or the risk manager understanding the workplace, the chemicals that are being used, the processes that are occurring, and the workplace controls that are available. And on the basis of that, classify workers into similar exposure groups. And then we come to this diamond in the middle, which is called exposure assessment. And here, the job of the industrial hygienist is to assess exposures for each similar exposure group of workers. And as you have noticed, probably, I'm using the word assess and not measure. Okay, and so the assessment can be done in a variety of ways, and we'll talk about each of those ways in this course later on, but it doesn't necessarily mean actually measuring the exposure using measurement device. You could use the result of your professional judgment. You could have a mathematical model. You could have some rule of thumb that you use. So there are a variety of ways in which exposure can be assessed and then compared to an exposure limit. And on the basis of this comparison, the industrial hygienist decides whether the exposure is acceptable, as you can see on the oval on the left-hand side, or unacceptable, which is on the right-hand side, or uncertain, which is the oval in the middle. If the exposure is acceptable, then you say, okay, great, I'll come back and reassess the exposures after some period of time. If it is unacceptable, I need to think about what exposure control measures I need to implement to make the exposures acceptable. And if the comparison is not possible and so you're uncertain, then you need to go out and collect more information. Maybe you need to make exposure measurements or understand the workplace better or do some more modeling. So all of those things are under the further information gathering. So let's talk a little bit in this slide about exposure variability and in particular about the similar exposure groups. So like I said, the industrial hygienist classifies workers who have similar exposures into these groups. They are similar but not identical. That's the key thing to remember. So you could have two workers who are doing the exact same job, but that does not mean that their exposures are going to be identical. They would be, in fact, significantly different in many cases because they may have different levels of training. One worker might be a little bit more careless in the way he or she does the job. One welder, for example, might have been welding for 10 years. The other one just started like last year. So their skill levels are different. Not only that, if you measure the same worker on 2 different days, the exposures would be different for a variety of reasons. And we'll talk about that later too. And so this distribution of exposures is called the exposure profile of that SEG. So to estimate the exposure profile, one simple way, of course, is to sample a limited number of workers from each SEG and then estimate the exposure distribution by understanding the statistics of the sampling and also an assumption about what the underlying exposure distribution is. As we start thinking about exposure variability, an important consequence of it is something we should keep in mind. And just to motivate that discussion, I want to do a little exercise with all of you. And since all of you are in remote locations, you can do it at your own pace. But what I'm showing in this slide are real data points. There's nothing wrong with the data. They were collected with the highest quality of QA and QC, so you cannot challenge the numbers. And what I would like you to think about, there are 5 different scenarios for xylene exposures, and the threshold limit value, or the TLV, or the safe limit for this, is 100 ppm. And for each scenario, there are varying numbers of monitoring data available. So, for example, in the first scenario, we have 2 data points available, 21 ppm and 68 parts per million. And your job as the industrial hygienist or risk manager is to decide whether, based on these 2 data points, the exposures of workers in this similar exposure group are acceptable or unacceptable. So in the first one, you see that there are 2 data points. They are both less than the exposure limit. And I'm not going to say anything, but you guys can play at your desk. You can mark yes or no. Same thing, now we move on to the second scenario. There are 5 data points, and 4 of them are less than half of the exposure limit, but 1 exceeds the exposure limit. So is this an acceptable or unacceptable scenario? The third scenario, there are 4 data points, all less than a quarter of the exposure limit. Is it acceptable or not? Scenario number 4, there's only 1 data point, which is very common. It's, in fact, the second most common number of data points available. And it's a very low number, so 5 parts per million. And then scenario 5, you have 5 data points, none of which exceed the exposure limit again. So again, your decision. And I don't know what your decisions are, but I have done this exercise many, many times with variety of groups of veteran industrial hygienists as well as novices, meaning who have been at their job for maybe a year or a couple of years, and also graduate students who are working towards their master's degree. And in every case, you get something like this. And this is an exposure assessment symposium that was held more than a decade ago. So you see how long I've been doing this with people. And in scenario number 1, an overwhelming majority say it's not acceptable. Same thing with scenario 2. Scenario 3, 92% of the participants say it's acceptable. Scenario 4, it's split 50-50. And scenario 5, again, there's more no's. It's like 2/3, 1/3 roughly. And the point is not at this point anyway, I don't want to say who's right or wrong, but the point is that there is an enormous diversity of opinion among industrial hygienists, practicing industrial hygienists, which is troubling in itself. It's as if you had your cholesterol level measurements and you went to one doctor and that doctor said, oh, everything is fine. It's an acceptable level of cholesterol. Whereas the second doctor says, no, it's unacceptable. And the third doctor says it's acceptable. So you don't want like such a big split. For example, in scenarios 4 and 5, there is a very big split between the practicing industrial hygienists. And that does not reflect well on the professional judgment of industrial hygienists. It's basically saying we don't know what we're doing in some sense. And what are the implications of this, at least in an industrial hygiene context? It means that different decisions are being made by the industrial hygienists and different levels of care are being provided. Just like if I went to one doctor versus another, I would get different levels of care. One person says, nothing, go on, have your steak. The second person says, you need a course of statins and need to check your diet and go on exercises. So in the same thing here, there are different levels of care, and more importantly, there are different levels of exposure risk. And one important way in which this scenario is different than that of the cholesterol is here I'm being put at a risk that I don't want for sure, compared to if I'm eating a steak versus not eating a steak. So you can imagine a situation where two industrial hygienists working for the same company, one in Brazil, one in China, they're doing exactly the same thing in the same type of facility, manufacturing the same product, but the workers in Brazil and China are subject to different levels of exposure risk. It's clearly not good for the profession to be in a situation like this. Why does this happen? Why are there inconsistencies in the judgments of industrial hygienists and risk managers? Well, we can speculate. There are a variety of reasons that could lead to this. It is more because of the training that they have had in interpreting monitoring data. And this itself you can further dig into in two different ways. One is if you have, let's say, 2 data or 5 or 6 data points, what exactly are you looking for? What is the mental rule you're using? Are you saying that all the data points are less than the exposure limit, so therefore it's okay? Well, that's certainly a rule you can use. Another rule is to say, what is the average of these measurements, and is the average less than the exposure limit? That's another rule you could use. What is the highest data point? Is that less than the exposure limit? So there are a variety of rules that you could be using. The important point about these rules is that it's in a black box in your head. Nobody knows the rule that you have used to make the decision that you did. And that is something we need to work on. We all need to have the same rule by which we make decisions. And that would bring consistency in our decision making, not only between industrial hygienists in the same company, but industrial hygienists as a profession. And it doesn't matter whether you are working for company A or company B, whether you are a private consultant, whether you're an academic industrial hygienist, given the same monitoring data, we should all arrive at the same decision.